Good morning once again. This is your regular teacher for the EMAS, Kumakujimano. Today we shall be looking at change of limits. Yesterday we looked at how to perform indefinite integration using substitution. We have come to apply the idea in change of limits. What it just means is that, for instance, um, yesterday the questions that we were tackling, example of such question is this is an indefinite integral. This indefinite integral meaning this question has no limit. Assuming they apply limits here, a and b, lower and upper limit, where a and b are integers. If we provide limits here for us to solve, how do we tackle it? Are we still going to maintain the warmer way we're doing it? Or is there going to be an extensive way or a different approach in tackling the same problem when the limits are introduced? This is what we are come to do today, this morning. So stay calm and watch. Do not be distracted by the other applications on your phone. Please, those who follow these video tutorials very keenly will, in fact, learn a lot before they even come to school January. So we'll pick our first question for the day. Let's pick our first question for the day. Question number 1 for the day. Today I'll solve only two questions. Then I'll give an assignment. So the first question, sorry, that was a mess up. First question for the day is it? We are supposed to find the integration of this function given limit, upper and lower limit. We are still going to apply substitution. At a point in time, we are going to change the value of these limits. Now, as we learned earlier on, if I want to apply the substitution approach, I will let another variable equal to what is under the radical sign. So we have u is equal to x plus 2. Then I can differentiate my function u. Then I'll have du over dx is equal to 1. This will imply my dx will be equal to du. So we are going to substitute u and then dx into this function. So it's going to be 1 over the square root of u du. Now we are integrating with respect to u. Remember, the values of these limits are the values of x. The values of these limits are the values of x and the values of u. So if we are integrating with respect to u, we cannot use these limits here. We can't use them here. So we have to change the limit because now the original question was different integration with respect to x. And the lower limit and the upper limit here given here are x values. Now we are going to integrate with respect to u. Hence, we must find the corresponding values for u, knowing that u is always x plus 2. Hence, our new limit is going to be x plus 2. In this case, lower limit minus 1 plus 2. And that will give us 1. So our lower limit is 1 Then our upper limit, ux plus 2 will mean 3 plus 2. And our upper limit is going to be 5. So here will be 5. Now that we have changed the limit, perform the substitution, we have no x, we can proceed with the normal approach. So we know this can be written as u raised to the power minus half du. Then we perform our normal integration. We increase the power of u by 1, which becomes positive half. Then we divide through by the result, which is half. This one is a definite integral, so the c is not relevant. Those who came to the Scholars Campus, we explained why the c is not relevant. Having integrated, I'll write my limits over here. Then I'll simplify the expression further. This becomes 2 raised to u raised to the power half, or 2 square root of half, lower limit, upper limit. Those who came to Scholars Campus were taught how to deal with these limits. In fact, if I have limits introduced into the integration, it means you substitute the upper limit, top number here, into the function, minus the substitution of the lower limit. So this becomes 2 into bracket square root of 5. Or I should have written 5 raised to the power half as introducing the upper limit, minus 2 square root of 1. This becomes 2 root 5 minus 2 in a third form. We can also use your calculator to get a decimal equivalent. You can also use your calculator to get a decimal equivalent. So in effect, change of limit is not something so weird. Since we have done limits, it is just to find the action, and then when we have done limits, when we were on Scholars Campus, the limit were the values of x. We substitute them into our integration. Upper limit minus lower limit, the substitution of upper limit minus the substitution of lower limit. But this time around, we are, by a substitution method, we are integrating respect to u. So we need to find out the value of u given those limit next. That is all. So we are going to go to the next question. As I said earlier on, today I will not solve more questions. I'll only solve 2 questions. And then I'll give you an assignment. If you don't understand, you just leave a voice note. I will respond. So the next question for today, we're going to look at our second question for today. Second question for today. And that will be the last question for today. So that's it. We are supposed to integrate this function in respect to x, given lower limit 0, upper limit 1. We'll first have to do our substitution. So let u is equal to x cubed plus 1. Then our du over dx, our du over dx will be equal to 2x squared plus 0, or 2x squared, implies our du over dx. Sorry, our dx. You have to make the the subject. So our dx is equal to du over 2a squared. Then we substitute the u and the dx as we were doing yesterday. That's why I'm telling you it is nothing new and it doesn't require me to solve many questions. So the two examples will be enough. So we're now going to integrate x squared u raised to the power half du over dx du over 2s squared. So this will take care of this. So we are integrating u raised to the power half dot 1 over 2 du. Then we need to find the value of our limit. The upper limit when x is equal to 0, lower limit when x is equal to 0, u will equal to 0 cube plus 1. That will give us 1 for the lower limit. And for when x is equal to 1, our u will equal to 1 cube plus 1. Now we equal to 2 for the upper limit. So we put it there, 2. Then we now perform the integration. So half, we increase the power by 1. Half plus 1 is 3 over 2. Use your calculator to confirm that. Then we divide the result by 3 over 2. We write our upper and lower limit here. So upper limit, the new limit, upper and lower is 1 and 2. We simplify this expression by reciprocating the denominator and multiply. U raised to the power 3 over 2. Upper and lower limit should be written beside the square brackets. We have 1/3 u raised to the power 3 over 2. We have finished our simplification. Then we now introduce our limit. So upper limit first. When u is equal to 2, we place in the u. So 2 is the power 3 over 2 minus substitution of the lower limits. 1 is over 3. Let's do the correction here. So 1 raised to the power 3 over 2. Then we simplify the expression further. 2 raised to the power 3 over 2 divided by 3. Continuing, simplifying further, we will have 2 root 2 over 3 minus 1 over 3. If you want the decimal equivalent, you can punch 0.62, 0.60 or 61 or something like that. 0.6 to one decimal place. The decimal equivalent. I'll also upload an assignment in the PDF form. You're supposed to submit your assignment by 1 p.m. Any assignment that is submitted after 1 p.m. you will look at. Thank you.